Thank you for the invitation to speak today. Regrettably, I can't be there in person, but nonetheless, greetings from Vienna here. So my name is Bradley Matthews, and I'm presenting the main findings of our report that was co-written by my colleagues Catherine Seuss, Bernie Ulrich, Michaela Gager, and Sabine Schindelbacher. We all work at the Environment Agency Austria, which also hosts the EMAP Center for Emissions Inventories and Projections under the Air Convention. Just to start off, thank you to many of the colleagues in the room for your feedback on the report, which you've provided over the last weeks. And so nothing here will be new, I assume, but for the others, I hope that this can shed some interesting light on where emissions currently stand. So a bit of context and an overview for the report. So we were also involved in the previous project where we led the work together with Vileveco from CH₄ on this review of reporting systems for black carbon emission inventories. You can see a picture on the right-hand side there. And within this project, we've kind of followed up that work to look at the extent of reporting on black carbon and methane under the respective, say, Air Convention and the United Nations Framework Convention on Climate Change. And we've looked at specifically the reporting of the Arctic Council member and observer countries. And of course, the reason for doing that, the context for doing that is the Arctic Council Framework for Action. This will be nothing new to those of you in the room, but nonetheless, I think it's important to recall some of the goals of this framework. So the Arctic Council members committed and also encouraged the observer countries to join in reducing methane emissions and also accelerating the decline of overall black carbon emissions. And as well as say this overall goal to reduce emissions in the Fairbanks Declaration of 2017, a aspirational goal was agreed upon to reduce emissions by 2025 by at least 25 to 33% below 2013 levels. Of course, it's important over the course of this period and generally beyond to monitor progress of the implementation of this Arctic Council framework. It's, by the way, I would say the only international framework that has set a, say, formal target or goal on black carbon emission reductions. This framework is monitored by the Arctic Council's expert group on black carbon and methane. And the monitoring of progress is done based on national reports that are submitted to the Arctic Council Secretariat every 2 years. Obviously, given the say current geopolitical landscape, there is arguably a gap in the monitoring of the framework. So the last publicly available national reports were submitted in 2020 and 2021. But also on top of that, regardless of the current geopolitics, some members and observers submitted their last reports back in 2017 or even 2015, and there are other countries that have yet to report emissions data under the Arctic Council framework. So with this synthesis report, which I will present today, we hope that we can maybe contribute a bit of a gap filler in terms of monitoring progress of the implementation of this framework. So as I say, we argue that this report provides an important and timely indication on recent black carbon and methane emission trends collectively of the Arctic Council members and observers, and also of the individual countries themselves. It's a synthesis report. So by that, I mean, what we've done is we've sourced data directly from the aforementioned Climate Convention, the UN UNFCCC for methane, and the UNEC Air Convention, where we find gaps in those data, we've approached respective inventory compilers from the countries. We've also looked in the literature for national estimates that have been compiled by national universities or expert institutions and brought those into the analysis. And we've supplemented those as well with independent emission estimates from regional and global data sets. You've heard before of the GAINS data set that's produced by EASA, but we've also included in this the emissions data set EDGAR that's produced by the European Commission's Joint Research Centre. A big thank you to the colleagues at the US EPA who kindly provided a 2020 emission inventory for the US. So that was really a big gap filler in our synthesis work. I'm going to now present, say the main findings or the main outcomes from the report. Arguably, this is more of a kind of context, but I think it's an important issue to raise here in this meeting. What we display here are basically two calendars for black carbon and methane, whereby each year represents a year for which emissions have been estimated and reported. In the orange color and per country, you can see the emission estimates, the years for which emission estimates have been reported under the Arctic Council, for both black carbon on the left, methane on the right. And also added there in blue, we have the emission time series that have so far been reported under the UNECE Air Convention for black carbon and under the UNFCCC for methane there in yellow. Obviously, in an ideal world, we would like to have nice lines spanning from 2010 to 2020. But of course, that's not the case. Here we consider only submissions up to the year 2022. And of course, we do see some gaps there in the emission time series that have been reported so far. And a particular gap that has to be pointed out is that of Russia. So far, Russia has reported under the previous chairmanships only back in 2015 with an estimate for 2013 for black carbon and 2010 to 2012 for methane. Under the UNECE Air Convention, Russia is yet to provide an estimate of black carbon emissions, a national total, or broken down into sectoral emissions. Of course, it's important to point out that emissions reporting of black carbon under the Air Convention is voluntary. So there's no say international treaty that's been violated there. But nonetheless, in terms of monitoring the progress of implementation and just generally monitoring the progress of black carbon emissions, of course, that's a big gap. What I do here is also present the same graph or the same table for the Arctic Council observers, whereby, say, the situation for the European observers actually looks relatively good, I would say. So almost complete reporting under the Air Convention, given that the last reports under the Arctic Council from 2020 or 2021. We also have reporting up to what would be the most recent year at that point, so up to 2018, even 2019 in the case of France. And in terms of methane, a similar kind of picture. Obviously, a big issue, though, are the Asian countries. So the Asian countries are all parties to the United Nations Framework Convention on Climate Change. However, only Japan is a Annex 1 country. So only Japan has been subject to the more stringent annual reporting requirement for its greenhouse gas inventories, including methane. Whereas South Korea, Singapore, India, and China are non-Annex 1 parties to the convention. So they've only been required to report within the scope of biennial update reports on national communications. And you can see there the the emission time series that are available per country is rather fragmented. With respect to black carbon emissions reporting, those countries, including Japan, are not UNEC member countries, therefore not parties to the Air Convention. So, of course, there is no reporting of black carbon that goes on by those countries. And under the Arctic Council, only Japan and South Korea have yet to report annual emission estimates for black carbon. Singapore, India, and China have yet to do that. And to just put that in context, I bring up an infographic from the last project, where you see the Arctic Council observers and members in terms of their emissions, and just to point out their emissions of black carbon, and just to point out there, China and India are huge contributors of black carbon emissions. They're the biggest emitters out of all the countries presented there. And of course, those gaps in reporting represent substantial gaps. And coming back to the aforementioned gap of Russia, you see also Russia is a big contributor of black carbon emissions in terms of the proximity of emissions, especially from gas flaring. Again, it's not just a big, say, contributor of emissions in absolute terms, but also in terms of Arctic effects. So there are some big gaps to be filled, and that's what we've tried to do with this report. And as I said before, we've taken a kind of synthesis approach to take the available inventory data under the Air Convention and the UNFCCC. We've supplemented that, or say supported that, with other national estimates that have been made available or were available. So in the case of the US has kindly provided an estimate for 2020. For Russia, Veronica Ginsburg, who was, I think, previously a Russian representative under the expert group on black carbon and methane, published, or rather was the lead author on a published Russian inventory on black carbon. So we've taken that into our synthesis, and there's been other examples of national estimates that we've included. And for example, a Chinese estimate that was reported in Systems and Science Data. And where we have gaps that still remain, we've taken a regional emission data set, the RIAS data set, for some of the Asian countries. For the synthesis, we've also had to do some gap filling work because of the years that are available. So with that gap filling, we've made sure that we have at least an estimate for 2013 and 2020, so that we can derive, say, relevant trends in emissions. And as I said before, we've supported those, or we've integrated into the analysis also estimates from the gains model that's been presented beforehand. And as I mentioned earlier, we've also included the data set, the EDGAR data set from the JRC. In the next couple of slides, I'm just going to present the collective emissions, aggregate emissions of all Arctic Council members and observers. What you see here is a graph with 6 panels. On the top row, we have the methane emissions going from left to right, the national emissions, so based on those reported emissions under the UNFCCC. In the middle there, we've got the gains estimates, and on the right-hand side, the EDGAR estimates. And underneath in the bottom row, we have the black carbon estimates, predominantly those reported under the UNECE or supplemented with national estimates, and again, middle and right, the gains and EDGAR estimates. And we've just divided those into kind of aggregates sectors. So in red, fuel combustion and industry. In blue, fugitive emissions from coal mining and also the oil and gas industries. In yellow, agriculture, and in pink, their waste, just to give you an impression of the kind of main, say, differences in terms of sectoral splits, the kind of trends that are going on within the sectors at this kind of collective level for the Arctic Council members. In 2020, according to those national estimates that we synthesized, methane emissions were estimated at about 42,000 gigagrams or kilotons. And of course, as you can see from the graph, that's kind of diverges from what the GAINS estimates generate. So according to GAINS, total methane emissions were estimated in 2020 at about 76,000 kilotons. But on the other hand, EDGAR also deviates from GAINS and is more similar to, say, the reported or the national estimates at 48,000 kilotons. One thing we notice with this synthesis work one thing we notice is that there is a lot of variation between the data sets, and it kind of also underlines that we can't use, say, these independent estimates as some kind of, say, validation yardstick, because the independent estimates themselves vary. But nonetheless, it's by looking at different sources of data, we can kind of indicate some uncertainties or confidence in terms of general trends or general emission levels. For example, black carbon, we have a different kind of agreement. Black carbon estimates generally agree well between the national estimates and GAINS, whereas EDGAR estimates those at a lower level. In 2020, according to national estimates, collective black carbon emissions were at 430 kilotons of black carbon, with GAINS estimating at about 460. With the EDGAR data set, we only have data up to 2018, but generally you can see there it's giving a lower estimate, the 2018 estimate at about 300 gigagrams or kilotons of black carbon. But I think of course, the absolute emissions are important. They're important to the atmosphere, but what's equally important to the atmosphere and policy making are the trends. And one thing that we saw, we looked at the trends between 2013 and 2020. And in terms of methane, we see a small reduction according to the national estimates of about 0.6% per year based on 2013 levels. But this is not corroborated by the GAINS and EDGAR estimates, which actually indicate an increase in emissions over that time, small in the case of EDGAR, more substantial in the case of GAINS. With respect to black carbon, all three data sets indicate that emissions have been reduced since 2013, but of course to varying extents. So in terms of the national estimates, since 2013 and using 2013 as the baseline, emissions have been reduced by about 2.3% per year, whereas GAINS and EDGAR estimate respectively declines of 1.7 and 1.8% per year. Just to touch upon the Arctic Council observers, which are of course also important emitters, larger emitters. I won't go into details of the emission levels, but rather concentrate on the trends. In this case, we see that according to all estimates, emissions have been slightly increasing for methane since 2013, albeit it has to be said that the methane emissions here and also the black carbon emissions here are based to a large extent on some of the gap filling procedures that were applied. But nonetheless, we see a kind of consistent picture in terms of the trend. The same can be said for black carbon. And in comparison to the Arctic Council members, we see larger, say, relative reductions over time. According to the national estimates, a reduction of 4.7% per year based on that 2013 baseline, and according to GAINS and EDGAR, respectively, 3 and 3.3% per year. So to put these findings into context, I think this is useful data that's provided. It kind of takes the temperature of where the members and observers collectively are in terms of progress on the framework for action. And of course, I think this synthesis gives a nice example of, say, the advantages that can be maybe gained by directly sourcing the data that's reported under the Air Convention and under the UNFCCC. albeit gap filling had to be applied, and this kind of underlines the need and continued need for independent estimates. And also beyond gap filling, the independent estimates can also be integrated in terms of, say, policy relevant estimates to, provide indications of confidence or uncertainty in the collective emission levels and trends. And to just come back to those trends which we presented, which we derived and that were presented previously, and going back to the main goals of the Arctic Council framework for action. We haven't seen, according to the data, say, compelling evidence of a reduction of methane emissions since 2013. On the contrary, most of the data sets indicate increases over that period. It's only in the case of national estimates for the Arctic Council members where we see a decline. But again, the goal is to substantially reduce emissions. So based on this current indication, one would have to conclude that more ambition is needed on methane. With respect to black carbon, the evidence is pretty clear that black carbon emissions of the observers and the members collectively are declining and have declined since 2013. The trends that we derived, let's kind of do a small thought experiment. If these trends were simply extrapolated into the future to 2025, if we take the national estimates, we would see that actually these trends would be consistent with achieving the goal of reducing emissions in 2025 by 25 to 33%. In the case of the Arctic Council members, that would constitute a reduction of 30% if extrapolated into the future. However, in the case of the members, if we took the trends from Gaines and Edgar and extrapolated those into the future to 2025, there we would end up with only a 20.4 or 21.6 reduction in emissions compared to the 2013 baseline. So just to provide some kind of perspectives on monitoring emissions in the future and generally reporting emissions in the future. So as I mentioned, directly sourcing the data from the Air Convention and the United Nations Framework Convention on Climate Change can help with say filling gaps, but nonetheless, even taking those data, gaps remain. And of course, what we presented here has to be considered in terms of the gap filling that was applied, and kind of underlines that there are still gaps within reporting generally, not just within the Arctic Council. But nonetheless, it's important to note a few developments within international climate and air pollution policy, which will, or at least could, lead to enhanced reporting of the countries under the respective conventions, but also potentially within the scope of the Arctic Council. So all Arctic Council members and observers are parties to the Paris Agreement, and starting in 2024, all will be obliged to report GHG emission inventories, including methane, on a biannual basis at least. So even in the immediate term, there is a clear kind of perspective on enhanced reporting, enhancement in terms of the national data that's available. And I think that can only be of benefit to monitoring the progress of the Arctic Council framework. I would say under the convention, maybe the horizons are more pessimistic. So black carbon remains a voluntary pollutant under its new reporting guidelines, which are relevant for submissions from 2024 onwards. And of course, with the convention, we have to note the geographic kind of limitation of the convention. So, of course, the Asian observers are not UNECE member states, and also Russia's reporting under the convention. Russia reports only the emissions occurring west of the Urals. So it's not a complete picture of Russian emissions for the whole territory. Nonetheless, within the convention, or spawned by the convention, has been the Forum for International Cooperation on Air Pollution. And I would say that definitely represents a forum and an opportunity for stimulating the sharing and exchange of emissions data and expertise on generating national emissions estimates for air pollutants, including black carbon. That should have a global perspective and could perhaps contribute to, say, more enhanced reporting by the observer states. So with that, I'm finished with the presentation. I'd like to thank you all for your attention, and I'm happy to take any questions.